Bismillahirrahmanirrahim. Assalamu alaikum and hello everybody. The topic of my presentation is evaluation of the fruit peel extracts as a green corrosion inhibitor for mild steel protection in acidic environment. First of all, I wish to say some appreciation words for the organizing committee to organize such a good event in a very difficult situation, and I hope this kind of activities will continue in the future. So this presentation having some steps. So let me just start with the profile of the Saudi Arabia, and because this study has been done in the Royal Commission Industrial City, which has the Jubail University College. That research has been done over there, and I will talk about what the material and the methods utilized in that study, and after presenting the result I will conclude this study. So Saudi Arabia is one of the country in the Gulf region. It has area about 2,250,000 kilometers square, and population almost reached 30 million, and it has lot of natural resources, especially the petroleum, natural gas, iron, and many minerals over there. And Saudi Arabia owns 25% of the world oil reserves, and it is fourth largest natural gas owner also. If you look into the GDP among the Gulf countries, the Saudi Arabia having the highest, around 750 billion dollars capital. Industrial setup in the Kingdom of Saudi Arabia is since uh, 18 1980 it has been flourished, and still it is growing, especially the industrial cities in the existing in the Jubail and the Yambu, one of the largest industrial setup in the world, and also the developing city Rasul Khair, which is also called as the mineral city. It contains a lot of minerals, and the Jubail industrial city too also in the way, and the Dammam industrial city also. These industries mainly consist of the oil and gas refineries and other thing, metal and mining industry, logistic, agrochemicals, and etc. So it has a huge industrial setup at one point, which is one of the recorded in the Guinness World Record also. uh, Wherever the industries operating, there are some problems also. One of the problem is the corrosion. This is actually we are facing in that region. So corrosion is in the metal, actually the deterioration of a metal as a result of chemical reaction. Everybody know that with the environment in the presence of moisture and the oxygen. And sometime we classify this corrosion, metal corrosion, into these eight classes, and all this type of the corrosion can cause damage to the equipment, and it can uh, interrupt the operation of the industry. If we only look into the production and manufacturing category, you can see that the cost of the corrosion maintenance is in $1 billion, $17.6 billion per annum. And if you see even other areas where the corrosion is happening, and you need to maintain that industry or the operation, the million and the $1 billion are required to handle this situation. In Saudi Arabia, as I told you, it has a lot of industrial setups and which are facing a lot of problems in the start of these industrial units. The corrosion problems are happening over there. One of the reason is that the Gulf environment is also corrosive because of the Gulf, and also refineries most of the time handle with the corrosive fluids, so which cause a lot of corrosion problem. So the work has been done, and there is still they are exploring much and much to reduce the cost of the maintenance and to continue the operation of the industry. Because of the shutdown, there are lot of economic problems are involved. So if there is any problem, there should be a solution. We can manage, and there are many methods. For example, cathodic protection, galvanization, coating with many type of the material available with advanced material, different techniques, automation, many methods are there. And also use of the corrosion inhibitor, especially in the online systems like boilers and the heat exchangers systems. We can use that. Corrosion inhibitors, I will concentrate on that because our study is related to that. In order to reduce the undesirable metal dissolution, the use of the inhibitors is one of the most practical method. And actually, it will cover the surface of the metal, and it will prevent the corrosion to start. Synthetic corrosion inhibitors are available. Herbal corrosion inhibitors are available. Generally, these are synthetic corrosion inhibitors are costly, as well as sometime they are toxic and hazardous in nature also. While the herbal corrosion inhibitors are mainly coming the herbal sources like plants, fruits, and the vegetables, and they are not dangerous, so not corrosive also. So this study, as I told you, we worked on that corrosion inhibitor, and we utilized the waste material from the fruits and the vegetables and other material. So why we use, actually these materials are environmental friendly, they are not hazardous and non-toxic, generally, and they are economically feasible also. They are competitive with the synthetic corrosion inhibitors, and also is available, and it can also has the twofold benefit, which can protect the environment from accumulation of the waste. We can utilize the waste material. So this study was done at Jubail University College under the Royal Commission funded research program. We worked for in this project. We handled some uh, uh, study in the corrosion area in some of the nearby industries, and this evaluation actually um, uh, consists of the production of the inhibitors from some herbal plants and fruit peels, and we try to use that inhibitor on the mild steel. And in this study, what I am presenting, the effect of this inhibitor on the mild steel in 1 SCl solution. We utilize various materials, including the rehan leaves, sweet melon peel, pomegranate, the skin of the fruits, banana peels, carrot, and many other material. And these extracts were obtained, and then corrosion inhibition in the studies were carried out on the material by weight loss method and the electrochemical techniques, which is also called as the potential dynamic polarization, at different temperatures, but at different concentration of the inhibitors, as well as at different temperatures. So in this we utilize the peel, and just simple methods we utilize to extract the inhibitor from that, and from that material we try to find out the different component in that. For example, uh, uh, I will just only talk about the sweet melon peel study. It belongs to cucurbitaceae family, and it contains the 14 types of the long chain fatty acid, and we found these materials are having lot of functional groups, and these functional groups actually are helping this phenomena, because it can adsorb on the surface of the metal, and by which the metal will be protected from the corrosion. So in the preparation of sample, simple steps we use, we uh, dry the sweet melon peels at ambient temperature around 10 to 15 days in the open environment, and it was summer, so it become dried very quickly, and then we put in the oven at around 50 degrees centigrade for 2 hours. Then we crush it, grind it, make the powder, and then extraction process was done in the 1 HCl and alcohol from the peel powder by utilizing the digestion, refluxing, and the filtration technique. After preparation, we use this solution to make the different concentration to utilize in the testing of the inhibitor. Well, we utilized two methods. First method was the weight loss method, in which we use the different concentration of the inhibitor from 0.05 to zero point 0.5 volume by volume percent, and temperature we tested at 295 to 333 Kelvin. You can see that we tested the blank, yani without inhibitor, and then also with the inhibitor. You can even see from here that the effect of this inhibitor, it is much clear solution as compared to this one here, corrosion appearing here. And we utilize the time span studies for 6 hour every batch study, and we utilize this water bath. In the gravimetric analysis, the percentage inhibition calculated based on this relationship, the weight loss in the blank, yani without inhibitor, minus the weight loss with the inhibitor, and per unit weight loss in the blank. So this inhibition percentage we checked for different concentration and different temperature also. The corrosion rate also calculated from this well-known formula in millimeter per year, and the W, we know that it is the weight loss, and the D is the density of the specimen. In our case, it is the mild steel, and A is the area of the exposure of this sample, and T is the time of the exposure. And in the electrochemical study, we also did that to confirm the phenomena and the potential of the corrosion inhibitor. In the corrosion, actually, we know that it is a electrochemical process of oxidation reduction. So what will happen during the corrosion? The electrons are released by the metal and then gained by the elements in the corroding solution. So there is a flow of current which we can measure, and from that we can find out the corrosion rate. So we use this method also, electrochemical study, and we find out the E core we measure from the potential state as an energy difference between the working electrode and the reference electrode. We also calculate the different energy, Gibbs energy, and other parameters. Here you can see that the results in the case of the sweet melon at different temperature, you can see that the weight loss with respect to the change in the concentration, with the increase in the concentration, the weight loss is decreasing. And at any one temperature, you can see that um, the increasing the temperature, the weight loss is increasing. So, and if you have the any one concentration with the increase in the temperature, you can see that the weight loss increasing. Similar behavior you can see that for the corrosion rate at different temperatures are observed. This is the data of the weight loss from the electrochemical study and the comparison with the weight loss method. In this method, we find out the E core, I core, and at different temperature. You can these values obtained from this analysis, and you can see that the graph between the potential versus the current density, and the inhibition efficiency when calculated, you can see that the difference between the weight loss method, the inhibition efficiency, as well as from the electrochemical study, and these are quite comparable. So it is supporting the result that the inhibition efficiency is increasing with the increase in the inhibitor concentration. And at the other temperature, 318 Kelvin, also you can see that the corrosion rate is decreasing and inhibition efficiency is increasing in the both cases, and these are also quite comparable. uh, and at 333 Kelvin also, you can see that the corrosion rate is decreasing and the inhibition efficiency increasing. So similar behavior we found in this temperature. And to get the more clear picture, you can see that here at different temperatures, study temperature, when the temperature was 295 Kelvin, so the inhibition efficiency was maximum around 70 from 25 to 70 percent at different concentration of the inhibitors. So if when we increase the temperature to 318 Kelvin, it reached to here. It increase inhibition efficiency increase with the temperature. It because it seems that the absorption increases with the increase in the temperature. And but when we further increase the temperature to 333 Kelvin, it comes down. So it reduces actually. This is interesting thing we found in this study. So what could be the reason? If you look into the results of the polarization, at 295 Kelvin, the I core value decreases from 265.4 to 10 from I6 ampere per centimeter square for the blank to 38.4 into 10 to the minus 6 ampere per centimeter square. So this is significant decrease in that one. And this study I am just comparing for 0.5% volume of the inhibitor, and enthalpy values calculated at 82.3 to 201.7 kilojoule per mole. And this the values of the enthalpy, the heat generation, and the current density, you can see that it reflect that it is the phenomena is the chemisoption, and the similar thing observed at 318 Kelvin temperature. At that temperature, enthalpy also within the similar range, uh, and the phenomena also seems to be a chemisoption. But when temperature reached to 333 Kelvin, you can see that the the value of the I core is reaching from 266.61 to 33.96, significant decrease, and enthalpy is only 22.5 to 70.4. There is a significant decrease in the enthalpy. So these differences of the I core enthalpy shows that it is a physics-option phenomena, which is a kind of the reversible adsorption phenomena. So you can see that as we know that physics option is because of the weak van der Waals forces, while the chemis option is is the bonding is the chemical bonding, which is more stronger, and chemisoption is irreversible. So with the increase in the temperature, it will sustain the bonding while in the physis option it is reversible. With the increase in the temperature, it the bonds will bonding will break, and this we saw when we did the study at 333 Kelvin. So that's why the inhibition efficiency was reducing at a higher temperature. And also you can see that the range of the enthalpy to 20 to 40 in the case of the physics option, and from 80 to 240 in the in the case of the chemis option. So this confirmed that the at temperature 295 and 318, the chemis option phenomena was occurring, and at higher temperature the physics option phenomena was occurring. And that's why at that temperature the inhibition efficiency reduced because the of the reversible adsorption phenomena. We also did the adsorption isotherm study. We used various isotherm model, Langmuir, Tamkin, Freundlich, and Fromkin, and we fitted the data on that, and we found that the best fit isotherm of the adsorption for the sweet melon is the Langmuir isotherm, as indicated here with the high value of the R square, which is showing that it is following the Langmuir isotherm. And uh, as a conclusion, we can say that the corrosion rate and inhibition efficiency is strongly dependent on the concentration of the inhibitor and the temperature. And the inhibition efficiency increases with the increase in the inhibitor concentration. And at this temperature, 295 and 318, the percentage of the inhibition efficiency increases, and enthalpy was 82.3 to 209 zero point 0.7 kilojoule per mole. Based on that, we can say that it is a chemisorption phenomena. While at temperature 333 Kelvin, at higher temperature, inhibition efficiency reduced, and also because of the values of the enthalpy as compared to the lower temperature, the values are low. This is showing that it is a physisorption phenomena. And we found that the surface coverage increases as the concentration of the inhibitor increases. It is due to the presence of those functional group which are adsorbing on the surface of the metal. So that is essentially so that the phenomena can be described by Langmuir, Temkin, Freundlich, and Fremkin isotherm. They are also fitted to that data. However, the best regression coefficient value obtained in the case of the Langmuir isotherm, and the study shows that the sweet melon peel can be utilized to uh, prepare the corrosion inhibitor, herbal corrosion inhibitor, which is safe and environment friendly to protect the metal, and it gives a very good results. And further study can be continue on this to find out more better efficiency. These are some of the publication we did for these studies in this project. These are the members of our project. Dr. Tariq Said is actually a chemist. He was leading this project. I am as an environmental engineer, I was there, and some other colleagues were working on that. So this work has been published, and still some papers are in the pipeline. Thank you so much for your attention and listening this presentation.